I'm Rainer, and today we're going to be doing a problem with a few forces, trying to find one of the forces. So, in this problem, we've got a block of mass m sitting on the ground, and there's friction on this ground, and we know the coefficient of kinetic friction, it's mu k. And it's being pulled to the left by a rope up at an angle theta, and being pulled to the right by a rope with a known tension of T2. We're trying to find the tension pulling by rope 1. So I'm going to draw a free body diagram, and I'm going to make my system the block. And so I know I've got a tension force, maybe T1 on block. I've got a rightward force, T2 on block. I know I've got a weight force pulling down, weight of earth on block. I definitely have a normal force pointing up, normal from ground on block, I'll say. And one other thing, this block is seen to accelerate to the right with an acceleration of a. And so I know that since it's slipping, and I know that I have friction, I should have some kinetic friction since it's slipping. And it should point opposite to the direction of slipping. And so it should point to the left. So I'll say F sub k ground on block. So at this point, I know most of what I want to know. What I need to know is tension from 1. And so what I might do is, well, there are actually a couple of ways, but I might sum my forces in the x direction. It makes a lot of sense to sum them in the x and the y. Let me go ahead and do both. So if I sum my forces in the x, I could say I've got T2 pointing to the right. I've got the friction force moving to the left, and I know that kinetic friction is always equal to mu times the normal force. So I'll say minus mu k normal ground on block, and then I'll say minus this x component of this T1. So in that case, this will be a horizontal theta, so I know it will be a cosine theta for the x component. I'll say minus T1 be cosine theta. That should be all my forces in the x direction, and those should sum up to the mass times the acceleration. And the acceleration is one that we know, and it's in the x direction, so I'm going to leave it as a rather than a sub x. Now, let me sum them in the y direction, because the one problem is I have no clue what this normal force is. So everything else I know or I want to know. Right now, I'm looking for T1, and that's this guy. Everything else is known, except for normal force. So let me sum these in the y direction. So if I sum them in the y, I get normal force pointing up in GB. I have the y component of tension 1 pulling up, so that's going to be plus, yes, I forgot to make some axes. So let me draw some axes on here, the standard ones that we always use, but it's important for me to show it before I write out these equations. And this equation fits in the x direction, and now in the positive y direction we'll do the same. So we'll also have a y component of T1, T1b sine theta this time, and then we'll have a downwards weight force, so I'll say minus maybe mg, and that equals m times a in the y direction. And then I look at this and I say, hey, this is just sliding across the ground, it's going in the horizontal direction only, there's no y acceleration, so this goes to 0. So at this point, it will be essentially 2 equations and 2 unknowns. I've got this T1 missing here, I've got this normal missing here, and I've got the normal and the T1 missing here too. But I've got 2 equations, I know everything else, and I can just solve the system of 2 equations and 2 unknowns. So I won't write out that in detail, but that will be left as an exercise to you.